x meters, where x is greater than 0, the length of the pitch is 20 meters more than its width. Given the perimeter of the pitch must be less than 300 meters, form a linear inequality in x. So let me just draw a sketch so I can picture what's happening here. Here's my rectangular pitch. We were told that the width of the pitch was x. So let me mark that on. We're told that the length of the pitch was 20 more than the width. So 20 more than x is x plus 20. And we're told that the perimeter of the pitch is less than 300. So the perimeter is all the way around the outside here. So we've got x plus 20 plus x plus 20 has to be less than 300. Collect up the like terms. So we've got 4x's plus the 20 plus 20, so plus 40, has to be less than 300. So we have formed a linear inequality in x. Part A done. Given that the area of the pitch must be greater than 4,800, so the area then will be the length times the width, and that has to be greater than 4,800. Then part C. Part B, we've formed a quadratic inequality. Part C, by solving your inequalities, find the set of possible values of x. So let's go back and solve both of these inequalities. So the linear one, let's first of all take the 40 away from both sides. So 4x has to be less than 260. And then we'll divide both sides by 4. So x has to be less than 260 divided by 4, which is 65. So x has to be less than 65 if the perimeter of the pitch is going to be less than 300. Next, for the quadratic, let's expand the brackets there. So x times x is x squared, x times 20 is 20x. Take the 4,800 away from both sides. Oops. And factorise. So we're going to have x plus 80 and x minus 60, because 80 times 60 is 4,800. And the 80 plus the minus 60 is 20. Right, it's a quadratic inequality, so let's just draw a little sketch. Factorising told me that my roots are going to be at minus 80 and plus 60. Oops. And now I can use the graph to find where my quadratic is above 0, which is over here and down here. Now, saying that x has to be less than minus 80 doesn't really make much sense in the context of this question. I can't have minus 80 meters, so we're not going to include that as part of our answer. It does make that quadratic inequality greater than 4,800, but it's not going to be a sensible answer for this question. But this here tells me that x has to be greater than 60. So if x is greater than 60, then yes, the area will be bigger than 4,800. But I need to also consider that x has to be less than 65, because the perimeter has to be less than 300. So I need to put both of those answers together. So x has to be bigger than 60, so the area is bigger than 4,800, but it also has to be less than 65 so that the perimeter is less than 300. So those are the sets of possible values of x.